Hi guys, welcome. This is Mr. Krieger. This is going to be lesson 4 from Unit 8 Part 2. We're going to be talking about proportions in a right triangle today. So let me show you what I mean. This triangle here is a right triangle. Now where's the right angle? The right angle will be given up here. Okay? Now this is just a regular triangle. We don't see any other angles here, any other triangles here. But if we draw in an altitude from C down to this side, which would be the hypotenuse of this right triangle, an altitude creates right angles, right? So this side is the hypotenuse. These are the legs. But now there are two new triangles in here, and we want to show that these two triangles, the one on the left and the one on the right, are similar, not only to each other, but that this triangle is actually similar to the big triangle, and this triangle is similar to the big triangle. Let me show you another diagram so you can understand. I made this so that you can appreciate what we're going to do. Here we have, I hope you can see this. Let me check the video, make it a little smaller. Here we have the triangle created. And these are the two triangles that were created by drawing in the altitude. So these two triangles should be similar to each other. This triangle should be similar to the big yellow one. This triangle should be similar to the big yellow one. And let me show you here first how that's going to be true. Well, first of all, let's take a look at how the pink triangle is similar to the big yellow triangle. Well, what we would need to do in order to get them to be similar, because if I just rotated this around and put this here, this doesn't look similar to the big yellow triangle. So what needs to be done? Well, actually what needs to be done is we're going to have to do a reflection and then a rotation so that this angle matches itself. Now you can see that this is parallel to that, like we've seen in other similar triangles, and then we would dilate it to make it large enough. The same thing could be said for this triangle. It needs to be reflected, rotated, and then enlarged, dilated, so that it would map onto the yellow triangle. Okay, so we can see how that worked. So here's why the triangles are similar. Each triangle has a right angle. Let's take a look at the big triangle here. Right angle here. There's a right angle in this triangle. There's a right angle in this triangle. So each triangle has a right angle. Let me make this a little smaller, bigger I mean, so you can see a little better. Each triangle has a right angle, and we know all right angles are congruent. Okay, and then each of the, well, at least for the smaller triangle and the big triangle, they have a reflexive angle here to make this triangle similar to this triangle. Let's go back to my model over here again. So this triangle, the yellow one, has a right angle here. This one's going to have a right angle here, and they both have angle B as a reflexive property. So that's going to make sure the triangles are similar to each other. Okay, so by the reflexive property, they have a shared angle. So that gives us the two angles we need to get angle-angle similarity. Now, using similarity transformations, why is the small triangle similar to the very large triangle? Well, I had shown you on that other prop that I had before that we needed to do a line reflection, a rotation, and a dilation. Rotation, line reflection, and dilation. And the same thing is going to be true for the medium-sized triangle and the very large triangle. We're going to need a rotation, line reflection, and dilation. Now, to get the these two triangles similar to each other, because they're actually standing next to each other this way, let's actually see. We would need to rotate around D and enlarge. There's another way to do it, and that is through a thing called the transitive property. Let me explain. Since we know from here the small triangle is similar to the big triangle, small triangle similar to the large triangle, and we know from here that the medium triangle is similar to the large triangle, then we can conclude, therefore, the small triangle is similar to the medium triangle. This happens to be, this logic here is called the transitive property. No one's really going to ask you about this, but it's the same property that basically says if A is equal to B and B is equal to C, then A is equal to C. That would be the conclusion, and that's the transitive property, okay? So now we see that all these triangles are similar to each other. Let's go back. Since the triangles are similar, their corresponding sides should be in proportion. The problem is it's sometimes hard to find the corresponding sides. So let me label this triangle for you so that we can actually see how to make some sense of it. First of all, we know that the side opposite in the big triangle, the right angle, that side, A to B, is the hypotenuse. And these would be the legs of that big triangle. I'm actually going to number these leg 1 and leg 2. And this line that we drew perpendicular to the hypotenuse is the altitude. Now we have two new segments here, and we'll call this point here D. This segment here is just like a portion of the hypotenuse, but it actually happens to be the side of this small triangle. We're just going to call that segment 1. I'm going to abbreviate it as seg 1 because I don't have enough room to write it. I want you to notice that segment 1 goes with leg 1, and I'll call this piece DB segment 2. And this segment is going to always be associated with leg 2. Okay, that's important to keep in mind. I'm going to come back to this diagram again, this prop that I had, because I think it's instructive, and I'm going to show you a few things about it. I'm going to set it up like this. Let me make the camera a little bigger so you can see the whole thing. Okay, so move this over a little bit. Okay. Let's start this way. This is the big triangle, altitude drawn. This is angle A, angle B, and the right angle up there is angle C. And we'll pull this point D over here. Now, this triangle, if we wanted to compare the corresponding sides of this pink triangle with the very large yellow triangle, I want you to notice that this side of the pink triangle is the hypotenuse of the pink triangle. In order to make that correspond to the yellow triangle, we need to flip this over, basically reflect it and rotate it. We can put it up there to match up with D, and we can see how they match. Well, angle A matched up with angle A. That was nice. Remember we talked about how the reflexive property made those angles equal, but the right angle is down here. Now we have to make sure the right angle is up there. So what are the sides that are in proportion? AD from the little triangle matches up with AC from the big triangle. And the hypotenuse from the little triangle is AC, and that matches up with AB. Now this is a little confusing to keep track of. I like to think about it like this. I want you to notice that in this big triangle, we have, and let's take a look at this little triangle. For the little triangle, this is the shortest side, which happens to match up. Look. This is the shortest side of the pink triangle, right? But this is the shortest side of the really big yellow triangle, right? So this side AD actually matches up with that side AC. And the hypotenuse of the little triangle is this. So it's funny because the hypotenuse of the little triangle is the same as the shorter leg of the really big triangle, but this side, which is the hypotenuse of the pink triangle, actually matches up with the hypotenuse of the yellow triangle. Now that's kind of hard to keep track of, so we have these shortcuts, and as long as you know the names or know what these parts are called, I'll go over them one more time, you'll be good because we have a few shortcuts that will let you make the proportions really easy. Give me one more second to adjust the video. Okay, remember, this is the hypotenuse of the big triangle, leg 1, leg 2, altitude, segment 1 goes with leg 1, segment 2 goes with leg 2. Oh, and it bled through because I didn't put something underneath. All right, so if you are given an altitude, or you're trying to find the altitude, you are going to use, and let me put this down. We're going to call this seg 1, and this is going to be seg 2. We're going to use a shortcut called SAS. Now, what SAS stands for is segment 1 is to the altitude as the altitude is to segment 2. That's a little 1 over there, okay? Okay, notice that we're going to use the altitude twice in this problem. And this shortcut is only used if the altitude is in the problem and neither of the legs are in the problem, okay? On the other hand, if you're given a leg or you want to find one of the legs, you're going to use this shortcut called HLLS, which we call hills. And this is the shortcut. It's the hypotenuse of the really big triangle, that whole thing, over a leg, let's call it leg A, equals leg A over segment A. Now you might be wondering what this A is. There are no A's here. What I'm saying here is that if you're using the leg 1, if we call A a variable and it's 1, then you're going to use that leg, that same leg again here, and the segment from that side of the triangle. So basically, if you're dealing with a problem, a triangle, that has to do with this leg, you're going to have to use this segment, not that segment. If you have a problem that involves this leg here, you've got to use this segment here, not that segment. Okay? Okay. In the hills, you must use entire hypotenuse. If you have to add the segments together, please do so. In other words, if your hypotenuse is in parts and you need the hypotenuse, you're going to have to add those segments together, okay? Okay, so now let's try a problem. Here we have a problem in right triangle ABC. CD is the altitude drawn to hypotenuse AB. If AD is 3 and DB is 12, find the length of altitude CD. So first ask yourself, is this going to be a problem that uses SAS or a problem that uses hills? Well, there's nothing on a leg, so no hills, right? Actually, literally think of hills as something that has to do with a hill. These are the hills, like in a real hill, like you'd climb up a hill or go down a hill. Well, this is not the hill, this is the altitude. You would use SAS because it involves altitudes. All right, so how do we set this up? Very simple. We're going to follow that format. It's, first of all, write down we're going to be using SAS. It's segment 1 over altitude equals altitude over segment 2. As I said before, altitude is going to be used twice. Each segment is going to be used once. 3 is to x as x is to 12. Cross multiply, this is a regular proportion. You get x squared equals 36. And you had to solve that. You get x is 6, therefore CD equals 6. This is how you solve a SAS problem. Okay? Very simple to set up. there shouldn't be anything on the legs, just something on the altitude. Okay, let's go take a look at the next problem. Okay, in right triangle ABC, altitude CD is drawn to hypotenuse AB. If AD is 6, DB is 24, find CD. Okay, again, similar kind of problem. So again, this is going to be a SAS problem. Okay, you are going to do segment 1 over altitude equals altitude over segment 2. You can try to set that up. 6 is to x as x is to 24. When you cross multiply, you get x squared equals 144. X is 12, so therefore CD equals 12. Okay? All right, let's try the next problem. We have the same situation, same diagram. AC is 10. AB, that whole thing is 20. And we want to find AD. So what do you think we're going to use here, hills or SAS? Clearly hills. There's nothing on the altitude, nothing here, but there's something on a leg. That's how we know it's going to be a hills problem. There's something on the leg. It's on the hill. So this is HLLS. It's going to be hypotenuse is to leg. That side is leg 1. Therefore, we're going to use leg 1 again. And we have to use the segment 1 on that side. That side of the triangle, or this little triangle, that's triangle 1, leg 1, and segment 1. And they gave us the whole hypotenuse as a whole, so that's going to be our hypotenuse. We're going to get hypotenuse is to leg 1. Whatever is here must go here if you're using one of these shortcuts. So if you're using this leg, you're going to use that leg again. And the segment is the piece that's directly underneath it. It matches up. That's going to be x. Simple to solve. 20x equals 100. Divide by 20, and you get x equals 5. AD equals 5. Okay? Let's go take a look at the next problem. All right, well, this one I don't need this for. Okay, for our last problem, it doesn't give us a diagram, but you have to be able to draw it. So when you draw your own diagram, what you need to know is you need to know, first of all, you always draw your diagram this way with the right angle here. That's easy enough. But it's very important that you place your letters in the appropriate spots. Well, first of all, it says CD is an altitude. D is not one of the endpoints of the triangle. That means C must be here. In order for, because D is not, this is triangle ABC, not triangle ABD. D can't be one of the vertexes of the triangle. It has to be part of that altitude instead. Okay? C has to be the right angle because C happens to be part of the triangle ABC. Since it's the only one that's part of the altitude, it has to be here. And then in terms of the other letters, it really doesn't matter if you call that A and that B. Okay? So now we could plug in what we know. If AD is 24 and DB is 3, what's the length of CB? Okay, think to yourself, what kind of problem is this? Is it going to be hills or SAS? Now you might think, well, this is in parts, so it must be SAS. But no, there's something on the hill and there's nothing on the altitude. So this must be hills, which is hypotenuse over leg. And this time we're using the leg from that side. It's going to be leg 2. We use the leg 2 again. We always use the same leg twice. And then it has to be this segment that we're using. It has to be the segment on the same side of the triangle. So that's going to be the proportion you're going to set up. Now, your hypotenuse, what is it? As we said before on a previous problem, if you need to, you must add that together. So your hypotenuse is going to be 27. So you're going to get 27. What do you think your leg's going to be? Well, there's only one leg, so it's got to be x, and you're going to use it again. And the segment has to match up with the leg, so the segment's going to be 3. Now we can cross multiply. X squared equals 81. And we know how to solve this. Square root it. X equals 9, so that CB is 9. Okay. So here's a tip for you, okay? draw your triangle so that the right angle is going to be here. It doesn't have to be done this way, but it'll be highly, highly recommended. And then the altitude is going to be like that, and is your altitude and the right angles. Then you must be very carefully put your letters on the triangle. Okay? By finding your right angle first. And you can do that by knowing that if they're telling you what the altitude is, the letter from the triangle that's also in the altitude has to be this letter. Okay? Okay, what do all these triangles have in common? They all must be right triangles. You cannot do this technique unless you have right triangles, and you need an altitude. You must have those things. And what are you looking for? You're finding a missing length. Okay, so hopefully you should be able to do your homework with this. We're going to do more practice with this in the next lesson. So try the homework, and if you have any questions, email me or put some comments in the video, and I'll be happy to answer any questions.